All right, so thanks everyone for joining the fourth quarter OpenG9 community call. Today we're going to go over some of the highlights of the fourth quarter release, and we'll have some presentations discussing some of the changes that have entered and how they impact users. So I'm going to share my screen. All right. So yeah, I'll just quickly go over some of the major release announcements. So in the latest release, we've added new JDWP capabilities for CRU checkpoint restore support, and this enables the ability to attach to a debugger on restore. So we've added the new suspend on restore parameter, so you can start the JVM and get it to suspend at the beginning of restore, and then attach a debugger at that point. So this just adds more control for those who want to do debugging on restore. I'll skip over the share class announcement as Hang will be doing presentation later. And just quickly outline some of the performance enhancements that have been done. So there's some performance improvements to system array copy and erase hash code on various platforms. And the performance of clone also is improved in all platforms. And some general improvements to unsafe and static final fields as well. So those are the major highlights. We'll now transition to the presentations. So Jack, are you ready?
Yeah, so I'll share my screen now.
Yeah, sounds good.
Can everyone hear me?
I can hear you.
Okay. Share screen. Okay. Okay, hey everyone. So I'm just gonna do a short presentation on the changes for Java 23 in Project Loom and the upcoming outlook for Java 24. Most of Project Loom is focused around virtual thread, so we'll start from here. So in Java 23, there were two JEPs associated with Project Loom. So JEP 480, structure concurrency, which is the third preview. There has been no changes from the previous version we previewed in Java 22. Scope values, which was also a third preview, JEP 481. There has been an introduction of an enhanced checked exception detection for Java C. Internally, JCL removed some of the intermittent generated classes to make everything a concrete interface so that Java C would be able to detect checked exceptions more correctly. From a user's perspective, there's no major changes that you're going to notice. The only thing you will see that's significant will be that you're going to get detections for check exceptions from Java C directly now. From the OpenJ9's perspective, we've improved the cache profiling for continuation. There's now a new runtime option for the JVM, which reports the usage of continuation caches. To discuss a bit more about this, there's an XX option, continuation cache. It used to be only for setting the cache sizes. Now there's an additional option which allows the print of a cache usage summary. As you can see on the bottom right corner, this is what it will look like if you have used this option. After the VM have completed execution, it will print to console or either log, whichever you decide for tracking the VM's output. The total caches missed and the average stack size. This is good for people who wish to change their default stack size if they're experiencing memory issues where constantly each virtual thread needing to increase the stack size. It's also very good indicator of the cache sizes you're using, whether it's suitable for your application or not. Now, there will be a blog post coming shortly in January to discuss a bit more than just the metrics. It will also talk about how to use these metrics to improve your application's performance and what tuning up availabilities will there be for based on the metrics. Now, there are future enhancements planned for Java 24, which will allow setting of custom initial stack sizes and additional profiling data available for maximum concurrent caches being used and how the continuation usage are varied between threads. Those will be coming in planned for Java 24. Now, for Java 24, there is also 3 JEPs. JEP 499 structure concurrency, which is the fourth preview. Still no changes from 23, which is the current one. We're still looking at getting more feedback from users before completely making it into a GA release. For scope values, this is the fourth preview. It removes the callware and runware methods and focused all the calls to scope value and bonded scope values as carrier call and carrier run. This would provide users with a more uniform interface where there's only 2 entry points. Now in Java 24, there's a newly introduced JEP 491 for synchronizing virtual thread without pinning. This primarily targets the synchronized keyword and object weight, where in the previous versions, the virtual thread will be pinned to the carrier under these circumstances, even though they have no way of progressing. Or just because the way that monitors work in Java, they're tied to the underlying carrier thread and not to the virtual thread. This JEP would allow the decoupling of monitors with the carrier thread, where we would allow the monitors to be associated directly with the virtual thread. Hence, we can unmount the virtual thread even when they're blocked from a monitor entry. I think that's it for Loom. Anyone have any questions?
Okay, thanks, Jack, for your presentation. We look forward to the blog post coming out early next year.
Okay,
All
thanks,
right.
Toby.
Right, so I'll pass it on to Lan and Longyu for testing updates.
Hi, can you hear me?
Yes, I can hear you.
Okay, perfect. I'm not gonna go through the details of all the changes that we have. Just the highlights. I think the key things that will impact the users. One is we do have the Aqua test pipeline that's.
Sorry, Lan, I just want to ask, do you have slides or?
Oh, sorry. I should. I don't have a slide, but I'm just gonna. I put the points on the meeting minutes.
Okay.
I can share that one.
Sure, go ahead.
Can you see my screen?
Yep.
Okay, perfect. Yeah. So I'm just gonna mention some key updates here. We have Aqua test pipeline for the release and it can be used for the regular testing. So it can be configured using a JSON file. As also it can be configured as a parameter. So at the runtime, we'll be able to launch all the tests being built. I'm planning to add this into the OpenJ9 Jenkins as well. So then the committers can be able to use that to launch a large number of the test pipelines. Another thing is we added a hotspot customer J9 target in OpenJDK bucket. So this is to allow the user to run any hotspot specific testing. This is currently mainly used for the serviceability test, but can be used for other hotspot specific tests as well. Moving forward, just want to highlight here, we're going to enable more Open JDK tests. As the initial launch a couple of years ago, we did disable certain tests because we don't have resources to look into it. Now when we get a little bit of spare cycle, we will take a look at those tests and then try to re-enable them back into the pipeline. One more thing is for the system test, we have some MOV testing, and I believe the byte buffer, we have a byte buffer failures in JDK 8. That's due to the MOV jar that's being generated is not having correct flag. So that triggers us to rebuild the jar. However, we are no longer be able to get the resource from the original CSV repo. Then the plan is that we're going to try to get the source code either from open repo. We have identified 2 open repos that contains MOV MOV source code, or we also have the source code inside the jar as well, so we try to decode from there. The bottom line is we will rebuild the MOV jar with the proper compilation flags, and hopefully that will resolve the byte buffer issues that we see in OpenJDK 8. And last but not least, through Semester of Code project, we did launch TrajX AI assisted issue triage and assignment at OpenJ9 repo in general. So any new issue that user open, the workflow will automatically kick off and then try to send the issue description to the AI model, the triage model that we have developed through the CAS project, and then try to recommend the component and the developers. Recently, we actually disabled the developer recommendation. We only display the component recommendation because we did notice that due to it's hard to predict it accurately due to people that are moving around, and some people may have more workload or taking vacations and stuff like that. So we will just focus on the component recommendation, and we are working on gradually increase the set of component that we have in the model. So you will see that more coming as we deploy the new model on that. And we are doing the surveys with OpenJDK developers, and for other users that also would like to participate in the survey, feel free to reach out to me through the Slack channel or just comment on the issue. That will also work as well. Then we can include you in the survey as well. And that's it from me. Any questions? No? Okay, Toby, back to you.
All right. Thanks, Lan, for the update.
No problem.
Pass it on to Henry for compiler performance enhancements.
Okay, thank you. Let me just find my slides here. Okay. All right. So this is just focusing on the Java JIT compiler performance enhancements that have gone into the most recent releases. So this so this just basically reiterates some of the information that was in the at the start of the minutes there, but so particularly these are some of the changes that have gone in that have provided cross-architecture improvements. So across x86 power, Z, and ARH64. So one of the improvements is for the performance of object.clone when it's operating on arrays, and that's something that went into the 0.48 release. It's something that we saw in a number of different benchmarks. So that provides a good general boost there. And in accessing the unsafe APIs, we noticed that the performance for accessing instance fields through those APIs was a little lower than it could have been. So that's an improvement that we've made in the 0.48 release. And so the unsafe APIs in particular are used in a number of places in the Java class libraries, and also in some other third-party libraries where people, for historical reasons, needed to use those APIs for performance reasons. And so this gives a little bit of a boost when those things are accessing instance fields. In addition to that, there's an improvement that was made for accessing static final fields of primitive types using sorry, that shouldn't say via unsafe APIs in this case. This is the general improvement for static final fields of primitive types. So in earlier versions of the JVM specification, it was possible to modify static final fields in various ways, and now the ways that those things can be modified are much more severely constrained. And so this is taking advantage of that, so that those fields can be treated as constants more often. And then finally, the last cross-platform improvement was for Java Lang invoke var handle, which is often used more and more in the Java class libraries and in third-party libraries. So that went into both the 0.47 for JDK 23 and the more recent 0.48 release. For JDKs 17 and up. It doesn't apply to JDK 8 and 11. And then finally, a couple of platform-specific improvements. On x86, we had improvements for system array copy, and that's in both 0.47 and 0.48. Most of the emphasis there was on arrays that are up to 32 bytes in length, but we've got additional tuning going on for arrays that are of up to 256 bytes in length. And then beyond that, things are pretty stable. There's also an additional improvement there. There's two pull requests that I mentioned. The second one is specific enhancements in situations where the JIT compiler knows at compile time the sizes of the arrays that are involved, so it can generate code that's specifically tailored to that size of array. And then finally, for Z architecture improvements, there are improvements that were implemented for the arrays.hashcode method for arrays of primitive types byte, char, short, and int. And that's specific to IBM Z13 and later hardware for JDKs 21 and 23. And that's taking advantage of the vector instructions that are available on those levels of hardware. And anybody have any questions on any of that? That's it for the JIT performance improvements. Right. Thank you.
Okay, thanks, Henry, for the presentation. And lastly, we'll go to Hung for share class cache updates.
Did you guys see my screen?
Yeah, I can see your screen.
Okay, so I'm going to talk about what's new in the share class cache in the 0.47 and 48. In 0.47, the -X share classes option now automatically enabled sharing open classes. So in previous releases, -X share classes option only turn on class sharing for all the JDK built-in class loaders and any subclass of URL class loaders. So in this release, we enable sharing for all class loaders under this option. So even for classes that we don't have a class path or module path information, we're still able to return that after extra class comparison. So with this feature, you don't get startup performance benefit from class loading, but you still get the startup performance benefits from the AOT. So you will still in our experiment you will still see about 11% performance in your application where we tried on Liberty and Tomcat, and there are some minor fixes related to this feature. So there were some flags that we missed in our class comparison. So it could return incorrect class in 0.46 if you explicitly use -X plus share offense. So that was fixed. That is already fixed in 0.47. So in 0.48, there's no more requirement for a consistent memory page size in the shared class cache. So previously, shared class cache can only be created and used on a particular machine, and but in cloud environments, you could it is possible that you could build your shared class cache in a machine and deploy in another node which has a different memory page size. So our previous behavior is that the shared class cache won't start up. So we have removed that requirement in 0.48. So you will still enjoy the benefit of shared class cache in your Docker image, even you have a different memory page size. Yeah, that's everything. Does anyone has questions? Okay, thank you. Back to you, Toby.
All right, thanks, Hong, for the presentation. So now we're at the any other business section of the call. So I'll just open the floor if anyone has anything they'd like to bring up. All right, if not, thanks everyone for joining the call, and thanks for everyone who contributed to the previous two releases. And yeah, we'll have another one of these calls next year after the JDK 24 release. So enjoy the rest of the year, everyone.